freeze up again. Okay, so we do zip is also possible in Linux. Uh, we've we had practiced the tar and these things. So here, gzip is also possible if you want to do. If you want to zip and zip, gzip is the command. Minus C means compress. So you can make a one file to zip, and then you can make another file to compress and append to the file. Zip two greater than sign, that means append, right? So let's try to do that. What I'm going to do is I'm going to make a file 321f1. I know you all have that. So change 321f1, and I can do VI editor my one.txt. You can just take a look what I am doing, and press I for insert. See, you can see here insert, and then where is my? It's very up top. Here, I want to make this high and make it bigger so that how can I read this? No, I cannot. From this point I can type and code whatever I want to do. Finally, I can save this file by pressing uppercase ZZ, but don't forget pressing escape button, the escape button, and the escape button and ZZ. Then we have this. Now I want to zip, gzip, using gzip. If you want to see what gzip is, then you need to see the manual, m gzip. Then you can see the manual, gzip. Similar commands that you see here, gzip or gunzip, zcat. Zcat means if you want to see the compress, if you want to see the content of the compressed file without uncompress it, then zcat. Isn't it so convenient, right? I'm not sure Windows systems has that. Without uncompress, without unzip, can you see the content? Yeah, a little bit of those, right? Yeah. It's new versions of Windows can do it. It's similar to that. Okay, so you can read this, but as you can see in the slide, we can do that. So currently I have one file. This file has my one.txt. Scroll that down, and file of that my one.txt is ASCII file, ASCII, which means plain text file. I want to do gzip minus c my one.txt to my one.gzip. Gz. Okay. Oh, I'm sorry. It should be greater than sign. So I have two files, my1.gz and my1.txt. If you see the size of this is original file, my1.txt. The size is 157 byte. My compressed file is 146 bytes. Compressed, right? Not whole a lot, but anyway, it is compressed. If you have so big files and so many files, will be more, right? And then I want to practice another. Yours one dot doc, and then I can do hello world mercy cyber security measures, and then I can do yours one dot dot. So cat yours one dot dot is that. So I want to zip minus c yours one dot, and I want to append to my one dot gz. That is append. So now you can see yours doc is 39. My one.txt is 157. If we add these two files, then the size of that is 196. If we compress that, then compressed file is 216, which is a little bigger than that. What happens? We do not know the exact reason, but one possible reason is that this gzip file needs to have some header file so that it should save how many files are compressed right now. So all that overhead information needs to be saved. That's why it is a little bigger than that. But if you have so many files and add them up, then definitely your gzip file will be much smaller than this. Okay. So if you want to do unzip, then g unzip and my one dot gz, then there is unzip. So what happens? So my one dot, so there's my one. So more my one is, see here, there's appended, right? Is it appended? Yeah, here. This is a previous file. And then finally I said, hello world mercy cybersecurity measures. They are, the second file is appended and compressed. Back to cybersecurity issue. Two files can be combined very easily, right? If you have two image files, combine them two. Combine those two image files into one name, and send it. So second file is appended. When you see the image files, you can see the first image only. So this is somehow steganography. I don't know. That is for the cybersecurity issues later, not in this class. Okay, that is a zip. Just try this. Okay, this is another command that we can see. If you type who, then it tells you who are logged in right now. Right now, root only, right? And host name is Kelly 5S. And those who, I can say, who am I? Then it tells me root. And I think we did this, right? And then date is a current date. If you want to see the process, what is the process in operating system? Process is nothing but command. Command that you currently typed, currently executed. So how many such things? If you type PS, then only two. Bash shell and PS. PS that I just entered, right? See here, second. This is that. And only one process is running for me. Bash is a Linux command, Linux shell. So that is nothing but operating system to me, right? Is there only two processes running on this Ubuntu system? There are a lot more than that, right? So if you say ps minus a, ps minus aux, then all the processes running on your system. I know those who are doing Ubuntu do not have this, right? Because you have no privileges. If you do not have any right now, who am I? Who am I? I'm root. If you are not root, then simply sudo and ps minus aux, then you can see all of this. Because there are so many processes available, so if you want to see who is there anything that, for example, genome, here this genome, how can I see if there is any process running under the name genome? Then this is a command, and then there is a pipe. Remember that last time I said pipe. What pipe can do is the left-hand side, outcome of left-hand side will be the input to the right-hand side. So this whole thing is a long list. That is the input to my grep command. What grep can do? Grep is pattern matching, right? I want to match. Match what? What do you want? What do I want to search? I want to search genome. From where? From left-hand side. Pipe. Usually I need to say something here after this keyword, but this is fed by the previous command, the other side of that pipe. So all of this is doing, it has a genome. See here, genome, and there may be some genome. Here, genome, here, genome. Yeah, all of this is something about genome, right? Here, genome. If there is anything related to the network, then you can see also net. So many, only two. Net NS or iNet, demand, and also myself, GrabNet. Okay. All right. Any question so far? Environmental variable, we'll do next. Not really. Pipe. Okay, this is very, very important. Privileges. Privileges. Right now I have files. All these files because I'm root, I need to root has almighty power. Not much that I can do here, but creating a use another login, another user, we have to do that in another module. In order to create a user, you have to do so many things. What shell that you need to have, what directory that will be your home directory, password and expiration, and there's a few other things that you have to define. So those things will be discussed in another module. But meanwhile, anyway, we have to do this. This is very important to concept. Let me first explain this. In Linux, there are three identities: owner, group, and world. Owner, group, and world. Owner is you, each individual log in, that is the owner. In Kelly, I logged in as the root, so I'm the owner. And each user may belong to one or more group. Sometimes you can be on an admin group, and also you can be, for example, student group, and also another group and another group. But technically, multiple groups that you can be involved in, but practically, let's say one group. Walls, by default, you will be in the world. Okay, so three identities always available in the Linux. There are three privileges. Three privileges. Privilege to read, privilege to write, privilege to execute. Those privileges can be controlled by number, which is very handy. We call that sticky bit. Your sticky bit. So bit, if you have integer 4, that is read. Integer 2 means write. Integer 1 means execute. Okay, so keep in mind, and real command will be practiced a little later. So by having 1, 2, and 4, you can combine. See here, number 1, 2, 3, 4, 5, 6, 7. If we add 0 or more, you can generate all possible 7 numbers by adding those. For example, if you want to read and write together, then you need to add them. 4 plus 2, then that is 6, like this. So if you have number 6, it means, oh, this guy has the right to read and right to write. if we have number 3, for example, number 3, then you don't have number 3 here. Therefore, you need to find out which one to be added. Therefore, number 3 will be obtained. 1 and 2 only. There's no other cases, right? 1 and 2, 1 plus 2, therefore you will have 3. 1 plus 2 means you have the right to execute, right to write. If you have number 1 only, okay, here, my course, number 1 only, if you see here, number 1, that's a primitive number, which means, oh, you can execute it. Okay? There is a command that assign the privilege is chmod. Ch means change. Mode, there's a privilege mode. Chmod is a command that you can set the privilege to each file, not to each person or user. So each object, each resource in your Linux has some specification of privileges so that it can tell whether you can read or not. Okay? So, here, we can practice it. Oops. Okay, so what happens here is that, see here sticky bits. These are the sticky bits. First bit tells us whether it is a directory or a single individual file. For example, if I want to make here under directory, then I have one more directory, right? This is under, just I created, therefore I have D, the first bit. If you have D, then this is the directory. All others, the file. That's the first bit. And then after that, you need to read 3 at once. 3 at once. First 3 bits tells you the privileges assigned to the owner. Next 3 bits indicates the privileges assigned to the group. For example, if you are in the group of root, then you have this right. If you are not in a particular group, then by default you are the owner of yours and you are the world. You are the world. Anyone, as far as you are, you can log in, then you are in the world. So, like this. So we can modify this. For example, I want to change mode. For example, 700 my 1. What happens? My 1, here's previously this, right? I changed here, my 1. I changed the mode by saying 711. What 7? First 7, number 7 defines the privileges of the owner. And second 0 defines the privileges to the group. And third number here 0 tells the privileges assigned to the world. 0 means if there is a 0, then no privileges at all, right? If you have from 0 to 7, then you have somehow some combinations of privileges, right? 0 means no privileges. So that you can see here, there's no privileges. Group and the world, no privileges. But myself, the owner has, previously owner has read and write. But I have one more, X. Why? Because I said 7 here. 7 means, if you see here, 7 means everything. Read, write, execute. Okay? My question then, how can I change the mode so that back to the previous, like this? How can I do that? chmod, that's a command, and number. Myself should read and write, right? So what is the number? Read and write. Number 1 is execute. Number 2 is write. Number 4 is read. So 2 plus 4 is 6. And then group. Group can read only, right? So read privileges, so 4. And the world, there is again 4. And then my 1. Enter. And see what it is. See here? This is new privileges, which was exactly the same. And one time it was like this. Color is white, right? If you have this gray blue, sky blue, then means folder, directory. And then it's green. Green means executable files. I'm not sure it is. I don't say it is executable. It is still it. When you say file, then it look into the file and it tells you the type of that file. So it gives you ASCII text. So that is correct. But if it's by the way, that is the reason. Let me check. If I do this and then file, yeah, still. Right now it is. If you have green, then that means executable. But not because the file itself is executable, but because the privilege itself. Okay. What else? That we did. Okay, so we did editor VI all. Okay, this is chapter 2, but I think we did half of chapter. I mean, another chapter also on the whiteboard. Okay, so next week, I'm glad everyone has somehow Ubuntu operating system ready. So from next week, we'll move much appropriate mode, appropriate speed. Okay. Okay, have a good night. I'll see you next week.